So the next topic is about the upcoming layer 2 system. So what we can expect from new layer 2 solutions. And the next speaker is a Bitcoin OG. He's a very talented developer and a guy that hardly speaks at Bitcoin conferences. Please let's give a warm applause to Peter Todd.
Thank you. Yes, hardly speak at Bitcoin conferences. I think this is the fourth I've done this month, but completely accurate. So yeah, I want to go talk about upcoming layer 2 systems, and if I'm going to do that, I really should go start with, well, what is a layer 2 system? What makes L2 L2? And if you're going to have an L2, surely you're going to have a L1, which is, Bitcoin itself. And when I think of L1, I really think about proof of work, and you can kind of call it transacting with passive security. The nature of proof of work is that your money just kind of sits there. Miners are incentivized to go and do the work that makes your money more and more secure. And frankly, after a couple confirmations, it's as secure as it's ever going to be. I mean, it is kind of how this stuff works, but importantly, you're just kind of sitting there. You don't have to actively do anything. You can go put money in a Bitcoin wallet, I don't know, maybe when your child is born, and come back 18 years later, and it will probably be just fine. And I can't think of anyone who would have done that. Oh, wait, maybe. But it's a nice system, and things built on top of Bitcoin in certain ways also have these properties. I mean, you may have heard of RGB, which is a client-side validation scheme for moving around tokens. And the important thing is RGB traces back to Bitcoin. Even though the data may not be on the chain, the security model is still L1. It's still directly related to spending and receiving Bitcoin outputs. My own open timestamps project, which admittedly isn't a financial thing, it timestamps data, but it's also a passive security example. And merge mining, finally, is another thing with sort of this kind of passive security. I'm not saying merge mining is secure, but the security model at least leverages this. So how does that compare to then L2? Yeah, man. There we go. So L2 systems, the definition can be a little fuzzy, but I think the key aspect of them is they're really about conglomerating transactions together and reacting in ways that go keep the system secure. Now, for the pure kind of conglomeration thing, you have the very old idea of payment channels, such as the CLTV payment channels. And this sort of predates Lightning, and we've really struggled coming up with a way to go build Lightning. And long story short is one of the steps along the way was the idea of a payment channel from one person to another where money could flow in one direction. And under the hood, this was really a multi-sig. We kind of had two people signing, and long story short, you give the other person the ability to take more and more money from that pool of money. But, there still is some level of some level of involvement there where someone else has to actually do something for this to work. And of course with Lightning, we make that process bidirectional, and now we have to react to something going wrong. Because with Lightning, in the past, you might have given the other party the ability to take more money from you than you owe them now. You have to be able to react to them doing the wrong thing, putting the wrong state on chain. And since you have to react to it, well, either you have to react or potentially a watchtower, but someone needs to do something in response to something bad happening. And it means that you can't just leave a Lightning channel sitting around for 18 years and expect it to definitely have the money still there. But often you can in reality because, the watchtower idea works pretty well. But it's still a level less security. And then finally you have Arc, which I'll go talk about later, but it's another example of a reactive kind of scheme and building on top of Bitcoin. And key to all this is, in my definition of an L2, you should be able to either unilaterally withdraw your money, or the system should be set in such a way that you can prevent a counterparty from benefiting from fraud. And Lightning is based on something called HTLCs, hash time-locked contracts. And long story short is an HTLC is really an output that could be on the chain that can be spent if either you know a message that hashes to a particular digest, or it can be spent in another way after a time has expired. And HTLCs are an actual example of both of these cases, either unilateral withdrawal or preventing the counterparty from benefiting from fraud. With a big HTLC, like if you have 1 Bitcoin in HTLC, and believe me, you absolutely can send an entire Bitcoin on Lightning. You just got to find people with enough channel capacity to do it, but you can do it. Well, that 1 Bitcoin, once that's actually in the HTLC while the payment's in flight, if that winds up on chain, absolutely you could spend it either the 2 ways. Either the timeout happens or the pre-image is revealed. That's a completely valid way to spend it. But let's go the other direction. What if you have 1 Satoshi? And, of course, you can go pay 1 Satoshi on Lightning. Can you represent 1 Satoshi as an on-chain transaction? No. I mean, technically, yeah, the protocol does allow it. We don't actually practice allow it in mempool standardness rules. But the key thing is, 1 Satoshi representing that on-chain costs more than 1 Satoshi in fees to actually redeem. But Lightning has this idea where, for really small amounts, rather than actually represented on-chain, we make it part of the fees of a transaction for a period of time. And I could get into more detail how exactly that works, which isn't really relevant. But the important thing is, when you're sending 1 Satoshi to someone on Lightning, along that path, no one can benefit from trying to steal that 1 Satoshi. They're going to spend more money in transaction fees than they benefit. So, both these cases work. Either you can unilaterally withdraw, or no one's going to benefit from fraud anyway. And the term L2 gets applied to a lot of things that I do not think are L2 systems. Certainly not under this definition. Liquid is, I think, your prime example. Is Liquid L2? Well, can you unilaterally withdraw? No. Liquid is ultimately a bank distributed across something like 30 different, functionaries, or maybe 16 different functionaries, something like that. But ultimately, it is a very fancy bank. It might be a nice audible one, but it is still a bank. They're still the ones ultimately in control of your Bitcoin. Cashew, it's kind of a more obvious version of this, and to their credit, I think fewer people involved in Cashew called it L2 system. And then state chains, and I don't really have time to get into the details, but it's an interesting example because it's kind of like the Liquid problem, except state chains has this curious thing where your counterparty, if they've been honest up to some moment in time, they can't steal your money. Now, obviously, they could have been dishonest in the past, but this is still better than a system where no matter how honest they've been, they can always steal your money. And to the credit for the state chains people, I think they've acknowledged this, and it's an interesting option, but it's not an L2. And another definition thing I want to cover is covenants. You've probably heard a lot about covenants because Twitter loves talking about covenants for some reason. Well, what is the reason? Because it can do interesting things with L2s. But the classes of covenants out there are really, and I should say that the definition of it's really systems provide restrictions on how transaction outputs can be spent that are more than just, hey, some guys have to go sign things. Some guys have to go sign things is a restriction that has existed since Bitcoin was released. But as it turns out, more complex restrictions than that are interesting. And Lightning actually already uses a form of covenants, which is just pre-signed transactions. If you and your counterparty have agreed to sign a transaction, in a sense that is a restriction on how the output can be spent, because you now have this way of spending it by just broadcasting that pre-signed transaction. It's not very interesting covenants, but it is there. Then you have check template verify, which is saying, well, if the transaction you're spending with, if we hash it in a certain way, if it meets this hash, then the transaction is allowed to happen. And that one's interesting because it's a different way of hashing the transaction, you can do this in advance, right? You can pre-calculate what this hash could have been. And of course, if you do that, well, you can then go create chains of this. Sig hash any prev out. Of course, this is where things get a little weird, which is sig hash any prev out was a proposed opcode that said, well, why don't we make a signature where the only requirement is the signature be applied to spending a particular type or like a particular transaction address, right? A particular script pub key. Not a particular output, but sort of a class of outputs. Of course, then some clever people figured out, hey, you can turn this into a covenant by playing games with ECC math. And again, I'm not going to have time to explain how, but it's an interesting example of you give people a tool and they can come, kind of figure out all kinds of interesting things to do. And then you kind of have opcat, which is just concatenate. Well, why is that a covenant? Well, because you can go take data, stick it on the stack in a script and say, hey, does this hash to something that's then signed as a Bitcoin transaction, right? It lets you manipulate data, which could be a Bitcoin transaction. And opcat's interesting because it's kind of the generic covenant enabler, right? You can do anything with it. And then you get a bunch of other things like, the Optivict proposal, and there's an enormous category of these things. They're all about specific types of L2 systems. And, why I bring this up is really, as I'll talk about later, what of this stuff to go and adopt depends on how we think L2 systems should evolve. Finally, I want one more little detour, which is all of these systems, and Lightning included, they wind up depending on mempool behavior. And to recap, the mempool of your Bitcoin node is a pool of like the set of transactions that you know about that aren't actually included in a block but could be. Well, Bitcoin nodes have mempools because somehow we got to get transactions to miners. And Bitcoin nodes propagate transactions from one node to another. And we sometimes inaccurately call all of the mempools out there the mempool. That's really not correct. It's mempools. But what's interesting about that is as we've developed L2 systems, we've realized that mempools are complex because often when you have more than one party in a transaction, there can be more than one party in output, there can be different ways of spending that output. And thus you can have multiple different transactions spending the same output. Thus, how do you choose which one? That's where transaction replacement comes in. Well, of course, once we figured out transaction replacement, then we realized that there's ways to prevent a transaction from being replaced. And that gets called transaction pinning. Well, what's transaction pinning? Imagine if Alice and Bob collectively are in control of an output. Alice might not want that output to be spent. If Alice can somehow broadcast a transaction that, as an example, is really big, but low fee rate, miners can't profitably mine that transaction. Now, obviously, the solution to this is, well, Bob creates a transaction that's much smaller and has a higher fee rate, right? Surely, miners will go mine the little one that pays a lot of money, right? Well, no, because our rules around replacing transaction and mempools are kind of broken. And there's a whole lot of issues like this that need to get fixed. I'm not going to have time to go explain every one, but it's, if you want to get into more detail, there's your homework to go read more on the Bitcoin Dev mailing list. And these are all things that kind of are being fixed. I mean, I have some proposals to go fix stuff myself, but this is a precondition to doing more interesting things with L2s. And finally, well, why do we want something better than Lightning? I mean, one obvious reason is because Lightning, at least right now, if you want to actually have full sovereignty over your funds, you need a UTXO. Right? You need to have at least one UTXO. Now, block sizes aren't that big. So as a rough guess, you could probably get on the order of maybe 100 million Lightning users with current block sizes that all have their own UTXOs. And that depends on how long you want to take to create those UTXOs, but that's sort of a number people go put around there. Of course, 100 million is less than 10 billion people. Population of our planet. And so a lot of people want some way of having people share UTXOs, Now, one way that people do it right now is things like Wallet of Satoshi, which are custodial. If you have a Wallet of Satoshi wallet, they're the ones in control of your money. You don't actually have any recourse if they do something wrong other than complaining on Twitter and maybe trying to sue them. All right, you're not in control of any private keys for any coins on chain. And this does not meet our criteria for an L2 system, right? You don't have unilateral withdrawal, and you don't have any in-system way of punishing fraud. You have an out-of-system way, complaining on Twitter, but that's not an in-system way. The other issue with Lightning is liquidity. We would like to have less money tied up in Lightning channels. And we'd like ways to go and move that, move the money assigned to Lightning channels around. Standard example being, well, how do you onboard someone to Lightning, right? If you load up Wallet of Satoshi, I can go send them 1 sat immediately. If you get them to use Phoenix, which is fully self-sovereign, they got to go pay a fee to create an on-chain transaction. And that's a very different experience of, hey, let me send you $1 versus, hey, let me send you $1. Oh, and yeah, the entire dollar is now used up for the opening of the Lightning channel. And finally, there's a problem with interactivity, which is, while things like watchtowers exist, people don't like the idea that you can't just leave a Lightning wallet sitting there indefinitely. And frankly, I'll say right now, I don't think anyone's really done a great job of solving interactivity. But that is one of the things people would like to go solve with better L2 systems. So, well, what's upcoming? What's kind of on the framework? Well, one is something very confusingly called L2. L2 is an L2. Another term for L2 is being LN symmetry, which really it should have been called that all along. But obviously the people who come up with the names like this, they're not the people who try to go give in-person talks. But it is what it is. So what does L2 do? Well, what does LN symmetry, I should say, do? It tries to reduce the complexity of Lightning by taking away the punishment. Remember, in Lightning right now, if the counterparty does something bad, you fix that problem by taking all their money. That's basically how it works. And LN symmetry says, well, hang on, what if we could just update the state of the channel, right? What if we could respond to the wrong transaction with the right transaction? And then no one needs to lose any money, and arguably that reduces complexity, right? You don't necessarily need to keep your backups perfectly up to date. You can go and load up a stale backup, and the other party will not necessarily take all your money, and these are all arguments. Of course, this may reduce complexity in environments where the counterparties roughly trust each other not to commit fraud. It may greatly increase the complexity in practice in the untrusted environments where people are trying to go and rip you off. Why? Well, LN symmetry makes ripping you off a lot cheaper, or at least trying to, because you don't actually have a punishment mechanism. Right? If I try to go rip you off with LN symmetry, all you can do is spend some more money to go fix the problem. But then, how have I lost anything? I might as well at least try. So I don't know that, LN symmetry actually works in practice. But LN symmetry certainly makes it easier to design Lightning channel systems where multiple people share the UTXO. And that's the next category I want to talk about, channel factories. So the idea of a channel factory, and there's a lot of different variations of it, but the basic idea is, why do we need to have one Lightning channel per UTXO? All right? Now remember, the trick with Lightning is that you're putting money into a UTXO, and then with your counterparty, you're exchanging half-signed transactions that could be turned into a transaction spending that UTXO, but 99.999% of the time you don't do that, right? You only do that if you actually need to go on chain. Hopefully you never have to. Hopefully the money kind of just stays there, and eventually maybe you'll close the channel by mutual cooperation, right? By going to the other party and saying, hey, I know what you owe me, you know what you owe me. Let's just spend the money in an efficient transaction to wherever we want it to go. Well, Channel Factory says, well, we can use the same trick a step back. Rather than having one transaction creating one channel, having one output creating one channel, why don't we make the transaction that creates the channels itself virtual? Why don't we make the UTXOs that we use for Lightning channels virtual? And the idea here is, well, you could have, say, 3 people, and they all agree, hey, we all want Lightning channels between each other. let's all put money into one UTXO, then sign a transaction that would take that UTXO and split it up into 3 different channels. But let's not put this transaction on the chain, right? We'll just let it sit there. If we need to, we can put it on there, in which case the channels become real, but we don't have to. Because sometime in the future, the 3 of us might say, you know what, we're done with our Lightning channels, let's collectively agree to take that pot of money that we all 3 have ownership of part of, and then figure out what to do with it later. And if this all works, well, we've saved chain space. And if we can somehow do this with, say, 100 people or 1,000 people, we potentially save a lot of chain space. And that's where you get advanced channel factories, which use all kinds of crazy things like op-evict, opcodes, and things like that to, rather than do this purely by collective agreement, have some kind of mechanism where, for instance, like one of the 1,000 people could drop out, right, without informing everyone else. And just op-evict as an example is basically quite a complex opcode that's meant to say, this pool of money that like 1,000 people have part of, let's evict one of those 1,000 people, take their money out of that pool, and create a transaction that's constrained to do exactly that. Now, needless to say, the idea of an op-evict is quite complex. It involves a lot of assumptions about exactly how does such a channel work. But with things like opcat, which are sort of generic data manipulation opcodes, maybe we can start prototyping these things. Of course, the catch is, if you write this stuff in sort of pure code that goes on the chain, you end up with very big transactions, which cost a lot of money and fees. And this may not be feasible, but you know, these are the kinds of trade-offs people are looking at. And the other main category of upcoming L2 systems, and the curious thing about this is there really are only 2 that I've found so far for Bitcoin. You know, in the Ethereum world, they kind of have things with roll-ups and whatnot, which are sort of their own class of things. But for things that people are actually seriously proposing for Bitcoin, these are really the 2 main categories. So, ARC. Well, ARC takes this idea of virtual UTXOs and says, rather than focusing on channels, why don't we just focus on the virtual UTXO, right? What if you could create virtual UTXOs and like spend and receive them? Well, if you have a service provider managing the process, turns out you can. And the way this works is it says, well, let's assume we have an ASP, right? And they have a pot of money, and in some defined time window, maybe it's 10 minutes, maybe it's an hour, maybe it's a day, they figure out all the people who want to own money with that ASP, and then they create a transaction that, using covenants, is constrained so that until some expiry point is reached, the only way to spend that money is by splitting it up into the virtual UTXOs. And this essentially creates a tree of transactions. So like, if it goes on chain, the money gets split up on multiple levels to eventually get to the UTXOs people actually want. Now, of course, like all these systems, if you have to go on chain, you've spent a ton of money in fees. That's not very useful. So why would this be useful? Well, remember what I said. You'd either have an expiry time being reached, or you split out this tree of virtual UTXOs. The expiry time is an important thing. Now let's suppose everyone in this room owns a virtual UTXO with my ARC service provider. And we set the expiry time to 4 weeks. So now you all have 4 weeks to do something with your money. One thing you could do with your money is buy a new virtual UTXO in a new period. And you can do this by basically signing a transaction that would spend your virtual UTXO and give the money back to me. All right? So now I'm in a position where either I wait till the expiry time is over, or if it somehow winds up on chain, I take that transaction and I get my money back. All right? Now I'm happy. And the assumption is none of you, or maybe very few of you, will ever actually put anything on chain. So the expiry time will be reached, and I'll get all my money back. And nothing will, hopefully nothing at least, will end up on chain. Now the only other thing is, why would you be willing to sign that transaction, right? Surely that would go, trust me, right? Well, we can use a clever trick, which is we say, every time you sign that transaction, you make that transaction spend an output in another ASP round. Now, the only way that transaction can be valid is if this other ASP round was created. Thus, you know that by giving me that money back, you're definitely going to get your money again in another round. All right? Now we have transferred money in such a way that you've unilateral withdrawal or recourse, and none of it had to end up on chain. And the neat thing about ARC is these are genuine virtual UTXOs, right? They really could be turned into a real thing really sitting on chain, which means you can open Lightning channels with them, right? Because again, a Lightning channel is just saying, hey, there's this UTXO that could be created that then could be gone and split up between some parties, and then you can go transact with Lightning Protocol on that. So hypothetically with ARC, if we have all the right software tools, we could achieve this sort of holy grail of, I want to send you 1 Satoshi over Lightning. Well, rather than like trying to send it over Lightning directly, I create a virtual UTXO that happens to be a Lightning channel with the right amount of money for you. And now you have your 1 Satoshi, and none of this ever has to go on chain. So ARC's pretty cool, potentially. The problem with all this is ARC has a liquidity problem, which is some ASP, and probably more than one ASP, every time money flows, money is changed from one virtual UTXO to another, some ASP has to back that money, right? Because those Bitcoins are still tied up until the expiry time is reached. Now, like, let's say hypothetically, we have this 4-week time period, and we assume everyone transfers their money out in the last week. Well, you basically have to go tie up, on average, like 1/4 of the entire value, just to allow people to stay self-sovereign. This is probably going to be expensive, because, there's something called the time value of money. I mean, if you want money, you got to go borrow it from someone. Like, it's worth something. And it's not going to be zero, because putting things on ARC ASPs and all this other clever stuff, they have real risks. Technical failures can happen. If I go loan you $1 million to run an ARC ASP, there's probably like a 5% chance every year that you screw up and I lose everything. So I'm probably going to want to charge 5% interest rates or more to make a profit. It's a hard problem. The other issue too is, like, if you use your money frequently, well, every single time you try to create a new virtual UTXO, you still have to go back. You still go. It's like the ASP still has to go back you up there. If we had ARC for like how we went and paid with our coffees, maybe if I have $1,000 in ARC, I might wind up with the ARC service provider having to front like $4,000 just so I can buy 4 coffees in a row. You probably wouldn't necessarily want to do it that way, but like there are a bunch of trade-offs here, and these things are kind of ugly. So I don't know that ARC's necessarily useful, which is unfortunate, because like I said, there really are only 2 classes of true L2 systems out there that people have come up with in Bitcoin. But, maybe it will be useful for something. And the final thing I want to go say for all of these L2s, all of these, better than Lightning systems is, if you want to scale more than Lightning, you got to think about what the failure case looks like. Now, what do I mean by failure case? Well, the whole point of Lightning is you can go on chain if necessary. With Lightning, the worst that can happen is basically one transaction, well, maybe more than one transaction, but roughly a transaction on average gets created to close out a Lightning channel. So your multiplier, if you will, between UTXOs and block space you need to solve the problem and get back to get back to the base case of everyone being sovereign, is like a transaction or two. What happens if everyone's in Arc and there's Arc service providers with 10,000 different people all on the same UTXO? What happens when that fails, right? Because again, the failure case in Arc is you're marching towards an expiry time where the ASP can take everything, and everyone needs to go on chain. If they don't go on chain, their money can be stolen. That's a hard deadline, and we may end up running out of block space. And frankly, I'm kind of worried about this stuff because with Lightning, we haven't actually seen big failures of Lightning service providers. A good example is Phoenix. It's a genuine sovereign wallet where you're in control of your money. Has a thing like Phoenix ever failed in a way where everyone had to go on chain and close out their channels? Well, not really on that scale. We've had big Lightning nodes shut down where, maybe 1,000 channels over a month go on chain. But that's still pretty small compared to even what Lightning could do right now. And, a thing with all this excitement about L2s is we just haven't explored how Lightning really works. So I'm not sure we're really ready for all this. But let's suppose we are. Let's go be reckless. Well, then the real question there is what kind of covenants do we go adopt? How do we modify the Bitcoin protocol? And while some of these systems, such as Arc, they can be demonstrated on a small scale without any changes to Bitcoin right now, for the most part, if you want to get the benefits of them and to actually have a sovereign wallet, you got to add something to the Bitcoin protocol. It might be sig hash any prov out. If you want to do something simple like L symmetry, it might be CTV. It might be some fancy tree manipulation thing, which is dedicated to one particular scheme. It might be opcat. And an interesting possibility is, and this is something that's been proposed fairly recent, is, well, why don't we go and fix scripting to be as generic as it was meant to be when Bitcoin was released? And if I remember correctly, this is something proposed recently by Rusty Russell, well-known Bitcoin dev. He hates this name for it, but I really like calling this Bitcoin Satoshi's vision. And we can, now that Craig Wright's probably going to wind up in jail for the rest of his life or something. So, but from the point of view of making all these things possible, if we add opcat, if we add a few more things, we can experiment with all this stuff, but the cost is, it's inefficient. You'll need a lot of chain space to be able to go do something as simple as create a single ARC-related transaction. Which again gets back to my concern of, well, maybe we push the limits too much. Which gets down to, maybe for now, doing nothing at all is okay too. And frankly, I kind of lean towards this because I do want to see these failures happen. I do want to see how Lightning plays out. Because we may be in a position where we're better off keeping Bitcoin a little smaller than literally everyone on the planet having a Lightning channel in exchange for the whole system actually working. But, ultimately it's the community to decide. So with that, thank you.